Hello, everyone, and welcome to a special bonus episode of the SD Times Live Microwebinar series on security testing. It's sponsored by HCL Software's OneTest. And in this final episode, we'll hear from OneTest product manager Martin Lescuyer, who will dive into API testing for Kubernetes. If you missed the first three episodes, they're available now under the webinars tab on sdtimes.com. So here to conclude the series, here's Martin.
Thank you very much, David, for the introduction. I'm very happy and pleased and delighted to be here, to be with you. It's a pleasure. And today, as David said, we are going to discuss around API testing for Kubernetes. What does it mean, and what are the challenges that users might be facing with this kind of architecture, and how transparent remoting, which is a capability that we shipped a couple of months ago, can help for this. But before we do that deep dive into Kubernetes and all that sort of things, I was thinking that it would be cool and maybe fun to quickly overview the different system architecture, how they did evolve over the last couple of decades, and see how testing also changed with these different practices and methodologies and sort of things like this. And so that started indeed back in the 90s. It was a long time before we were talking about Kubernetes in every way. It was years when I started to work, and I don't know if some of you guys remember, but computers were looking at something like this, sort of dirty white boxes. I can remember how noisy the fans were and how heavy the screen was. I can perfectly remember the clicks of the keyboard and all that sort of things. It was really weird. As you can see today, things changed a little bit. But then, yes, we were using that sort of computers, and what kind of applications we were developing. And they were monolithic stuff, big piece of code with no or few or no communication. There were no networking. There were really simple single executable things. We were not doing lots of things. Well, mainly, I think we were trying to replace that sort of little thing, which I don't even know the word. How is this called? A file, a paper file, or whatever, that's kind of things. When you were going to the doctor, he was searching you in this, rolling the papers and saying, oh, I found you here. So yeah, we were trying to sort of automate these and providing queries for people, quick queries saying, I want to see those, and possibly making a little bit of statistics around those databases. But yeah, that's kind of things we were doing. So very basic things. And as things were basic, the tests were, well, you had to sit in front of that green screen machine or whatever and play with the menus, navigate with those menus and verify that you fill data, you retrieve data. Well, that's okay. It was really easy. Really easy, but actually not formalized. It was a little bit of chaos everywhere. There were no timeout. As I said, there was no network, no connection refuse, there were nothing like this, and no lab management, no complex things. And then a little bit later came the notice with, early windowing systems giving really weird errors. People were getting maybe angry with their computers sometimes, from time to time. I think we all know this and we'll remember this. So yeah, that identified the time needed for a change in the system architectures. And we split those big monolithic applications into something which was much more modular. With shared component, we were able to reuse components, share components between teams. We were not starting everything from scratch from a project to another one. And to solve the issues we had with scalability, we were able to sit in front of two people in front of the same applications by those client-server architectures. That was probably early 2000, something like this. Machines start talking with internet in the middle. And yeah, that solved lots of issues, particularly around scalability and things like this. As I said, in terms of testing, that was a little bit a chaos up to a point where someone said, well, we're going to do these V diagrams. And that had first time where testing stages were clearly and formally identified in the life of the project. But so the issue with this is that you had to write everything down on a piece of paper and write and write and write again and again and again until you write the very first line of code. And when you did so, when you wrote your first line of code, you said, hey, that just can't work. It will not work this way because it was misdesigned, badly designed, or things like this. So you had to go back to the design stage, make change in the papers, and so on and so on. And so when came up testing, that was the end of the project. So yeah, it was cool, but end date of projects were really random, not deterministic. It was really an issue. Then, so continuing the journey from monolithic things we went through SOA in something like 2010, I think 2010, and now we continue our journey towards splitting those monolithic applications. And we are talking now about microservices. So those little blocks, little building blocks that does very simple things through their API. And in terms of methodology, we all agreed that it was not possible to write everything well with no bugs from the first time. So we came back with a much more iterative process, which is the one we know today with Agile methodology, where we design permanently code and test and everything each sprint, so leading us to the continuous testing we are pushing for, and all the CI/CD things that we know today. So now you can talk about microservices that we are using today without mentioning Kubernetes. So Kubernetes is something that allows containerization. So it's made of it's a cluster. A cluster is made of nodes. A node is made of pods, and pods allow to run some containers inside each pod. And so those pods are connected by a network, and each service inside those containers are talking through their API, right? So it provides a very good isolation, runtime environment isolation. So when a container crashes, it doesn't put the overall system at risk in any case. And Kubernetes is even able to kick off some new containers, to kick up some new pod in order to face high demands. For example, there are load balancing things and all that sort of things together. But now something which is quite really not easy to do in those containerized and cloud environment is it's often very difficult to be selective in the services that you want to test. So for example, if you look at a typical Kubernetes application is, for example, it's made of a number of containers and services within those containers, whether they are database services, whether they are resource monitoring services, treatment services, any kind of things, all sort of things that sits behind this application. And by default, the only way that users have to access this application is to enter into the system through this external application API, whether it's published or not, right? So anytime you need to interact with this application, you need to send requests through this ingress box that acts as a gateway. You call that gateway, ingress, egress controller, whatever, to this box, who acts as a man in the middle, in between them, and completely orchestrate the request that you send and the response that you get from the system. So that might be fine if you consider this application as a black box, and if you don't need to enter into this application. But if for example, I am a developer of that particular pod, and I want to test this pod through its API, sorry, because for example, its API is not the same that the overall application API. Well, you just cannot do this, right? Because the system won't let you get into this system that way. You have to go through this green stuff in order to be able to go into the system. So what we'll build basically is a middle-range fortress, something really secured, really nice, but in terms of testing, if you, as soon as you need to access internal things, you're in trouble. And what we're telling with the testing tool, so for example, HCL OneTest, but it's true for any other testing tool, that when you have an application like this, you can have a UI test that with what you automate filling data into a form and clicking on submit on that data, and then it gets propagated into the system, and probably something is written in the database. And what we recommend is that you then write an API test, connect to this database and make sure that the data that should have been written has actually been written, right? What's expected has actually happened. And so the reality that you just can't do this. And this is where transparent remoting depass that. So transparent remoting is a capability that is included in HCL OneTest, allows users to provide the Kubernetes configuration to OneTest API such that now it can get connected with any individual box inside that system, right? So now, rather than going through that gateway to interact with those services, you definitely can act with each individual API of any of the internal services because you have all visibility inside the cluster. So simply by providing a very simple configuration file, which is we are not modifying anything inside the cluster. There is nothing that needs to be modified, but simply by providing information about the cluster, OneTest API can get connected to any of these internal things. So if you are definitely involved into Kubernetes development, and if, for example, as a tester or as a microservice developer, you want to access the individual API inside that cluster and be able to interact with these APIs rather than going through the external application API. This is where definitely transparent remoting will help you to get this because it makes it transparent. You are accessing the microservice just if it was not in the cluster, but it is in the cluster deployed, but it's just transparent, right? So it makes you transparent this access to your internal system, to your internal services, to any of these, whether they are database, whether there are services, any kind of things. Again, we don't need to modify anything inside the cluster, just provide the right permissions and configurations to HCL OneTest, which is really cool stuff. So again, so if you are interested in some more information about this, you can go to our website and get information. And will be really happy to answer any question that you have concerning these. You can reach me on LinkedIn, wherever you want. I'll be happy to make answers about these.
Excellent presentation, Martin. Thank you very much. It's certainly good insights into what's involved in testing these very complex systems. And I hope, as you said, folks will follow up with you to get a little bit more information on that.
Well, yeah, please do. Yes. You should not hesitate a second.
I'm sure they'll hop on it right away and reach out to you. To all our listeners, thank you again for attending. We always appreciate your participation in these things. And until next time, I'm Dave Rubinstein, Editor-in-Chief. So long for now.